just be of people's personal space and preferences. We're here to learn about R, and that should be the focus. And as an organisation, we prioritise marginalised people's safety over privileged people's comfort. Um, so that's who we will favour in any dispute. Um, so if you need to report an issue, hopefully not, but sometimes, this is why we have a code of conduct. Sometimes bad things happen. So if you need to report anything, you can DM myself or Jockey, or you can email reporting@ourladies.org if you feel more comfortable with that. Okay. And we'd love for you to get involved in the community. So Our Ladies Remote, as I say, is a chapter. This is just a one-off event, and it will provide a great opportunity for learning, we hope. But there's only so much networking you can do on Zoom. And so we encourage you to join our Slack community. Now, hopefully this QR code will work because I literally set it up before the meeting. Um, so it would be great if you would like to test it out now. Um, and what it should do is take you to a form, a little sign up form, which explains again about the group. And there's a few questions to fill in. Um, and what will happen is you'll get sent an email after signing that form with a link to join the Slack. And it also reminds you about our meetup group, which probably most of you have seen, given that you're here. Um, and I think that's about it. Um, and if you make it to a Slack group and you're not a member yet, then do introduce yourself in the welcome channel. Some things you might say about what your current situation is. Are you working? Are you a full-time carer? Are you a student? Where are you in the world? That's always an interesting thing to know. Um, and what is your background in R? Are you completely new? Have you been using it for years? Are you specialist in something particular? Um, those are great things to know about you when you join, so that we can talk about our shared interests. And we'd really like people to join the organizing team as well. So if you have a little bit of time and you think you could contribute, and Jockey has sort of sketched out a bit of a plan for things coming this year. So we have an idea of what we want to do. And so that's a good time to join the organizing team because we have a plan and it's just about actioning it. So you can help shape some of those events, liaise with some of the presenters that we've got lined up, and help promote events on Meetup or social media. Any of those little tasks that are involved in organizing an event like this, so that other people, so that you and other people can enjoy this sort of event. So do have a think about it. Reach out to Njoki or myself on the Slack. I put a link in these slides to the Getting Starting guide, and in a moment, once I've finished going through the slides, I'll give you a link to the slides, so you don't have to busily write all these things down now. I'll give you the whole slide link. Did we say anything else? I think that might have been all we wanted to say right now. Yeah, so before I will forget, I will share these slides, and you probably don't need to edit them. Let's put the comment. All right. And then we can hand over to Ted.
Yep. Great.
Brilliant.
So I'm going to post a link I'm going to share my screen in just a second. And thank you, Njoki, for inviting me. This is definitely my pleasure and my honor to, pr basically do this workshop for everyone. Okay, so I'm putting a link to the website. So all of the materials are going to be available via there. One second. Is everyone able to see my screen? Just give me a thumbs up if you can. Okay, great. Thanks, Martine. And thanks, everyone. Okay. Stop that, Google. So, welcome to a gradual introduction to Shiny. I've given this workshop many times over the years. It's been every time I give I learn something new to kind of make it better. Just in terms of everything, this started like a long time ago. I originally gave this workshop in 2018. You're probably not that interested in that. But anyways, I like to talk about the learning objectives. So let's talk about it. So learning the basic architecture of Shiny apps. Learning how there's two components to Shiny apps, a server and UI, and understand how they communicate with each other. Add ggplot2 code to our app and display it. Well, we'll add a control to control the coloring of our ggplot. And then we're going to make a reactive data set using what are called reactive expressions, and we'll basically control that with a slider. If we have time, I will show you how to do kind of tooltips with a package called Plotly. Um, Unfortunately, Plotly seems to be sunsetting. I was trying to get material ready for a different package, but I didn't have time. Okay, I'm going to put a link to the Posit Cloud project. I hope everyone had a chance to sign up for a free Posit Cloud account. Um, and so when you first sign into the Posit Cloud project, wait, one second. So you'll see that it says temporary copy up here. So what you want to do is save a permanent copy to your own workspace. So that will be your own copy. You can do everything you want to it. You can take notes in it. It's not going to affect anyone else's project. So just give me a quick show of thumbs to everyone who's managed to get into the project. Okay, one. Wonderful. Okay, great. Great. So I'm going to move forward, but we will take our time. Again, this is meant to be kind of a gentle introduction, not me, basically giving you too much information at once. So I'm really hoping that this will help you out in the concepts. So we'll start with the slides. So I'm going to put a link to the slides. So does that include ggplotly? So yeah, I am not 100. There was actually an article, and I'm trying to remember who put it out. I think it was our Open Sci. They put some articles about alternatives to Plotly. I'll see if I can dig that up. The one that really seems to be like kind of a good substitute is ggiraf. Um, so here's a link to the slides. So we're going to move over to the slides, and then we'll kind of do some slides, and then we'll jump into the project and try things out. And of course, Zoom just loves to give that um, stupid menu bar. But anyways, okay. So let's get into the slides. So if I already put a link to slides in chat, this link works as well. Unfortunately, Bitly now has commercials, so it will show you a commercial between now and then. I apologize for that, but yeah, they're trying to monetize their platform, I suppose. I will probably not use them in the future because I think that's really kind of crummy. Um, so there is an Our Lady's Code of Conduct. I usually run this workshop with another code of conduct. I'm going to basically defer to Our Lady's Code of Conduct. But just again, I am very big on psychological safety. I really want people to feel okay to ask questions. I feel like I was having a conversation with another educator, and I feel like a lot of what I do is undoing what terrible math teachers did to us at a younger age. So I really want you to normalize your curiosity. I want you to basically get curious about this. Okay, so just a quick introduction. So my name is Ted Laderas, pronouns he and him. I'm the director of training and community for what's called the Data Science Lab at Fred Hutch Cancer Center. So there's a link to that. There is a link to us. So there are some online materials. Unfortunately, we only train within what's called the Fred Hutch Consortium, but you have there's a number of online materials and stuff. So if you're interested, of particular interest are what we're calling data snacks. So these are kind of cool Python R and tricks for working with data. I spent a lot of time kind of working with WebR and Pyodide, and these are basically executable tutorials. So just a little introduction to the data science lab. I'm also certified as an RStudio Carpentries instructor, very influential in like how I teach. If you have attended the Cascadia R conference, I co-founded that way back when. And here's a link to my website. Let's skip the introduction since we kind of already did that with the icebreaker, and let's jump into what is Shiny. I think everyone here knows what Shiny is, but just so we're all on the same page, I think of it as a web-based framework for interactive visuals. Um, and obviously, it was developed by Joe Cheng in our studio. It's grown by a tremendous amount. There's all sorts of extensions and kind of abilities that have been added. I'll talk a little bit about some of those at the end. Um, and the main thing to know with Shiny is that it's server-based. So it requires an installation of R on a remote machine to work. That machine has to be accessible via the web. We'll talk about kind of what are your kind of opportunities to kind of present Shiny apps, both kind of publicly and privately at the end. So just in terms of motivation, really, I find that Shiny is the real use case for Shiny is to help people wonder about data. So you see something, you see an outlier, and you're like, I wonder what that's all about. So it lets you dive deeper and kind of understand what exactly is going on with your data. Um, Obviously, dashboards are a big thing in Shiny as well. And the nice thing about Shiny is it leverages R and its visualization tools. So if you know ggplot2 and a little dplyr, you're ready to jump into Shiny. Okay, so this is kind of going to be our first section. We're going to talk about the basic Shiny app architecture. Um, So this is a great illustration from Vivian Peng, and this is a Shiny app. It's a minimal Shiny app. It doesn't do anything, but at least the main point of this figure is to introduce you to the components of a Shiny app. So the first is you call Shiny using library. But the next part you'll see is a UI component. And these have to be named UI and server, I believe. Although I think if you can change these, but in general, I like to use as convention. So UI, as you might guess, contains user interface components. So it might be plots that you generate, but also controls. So if you have a slider to filter data, or you have like, buttons to kind of select categories and things like that. So the second component is a server. Main thing to note about server is you'll notice that it's actually a function. So this one of the key things about Shiny that like I noticed with people, and we'll get into this in just a second, is the difference between writing code and UI and server. So we'll get into that in just a second. Finally, once we've defined those components, we can run the Shiny app using the Shiny app or Shiny app command. and giving it the UI and server components. So this is what actually spins up the Shiny app. And again, if you have any questions, happy to answer them along the way. So put them in chat if you have any questions. Okay, so this is just me kind of reiterating what I just said. But one thing to notice is that the UI component is usually defined within parentheses. So when you are adding multiple elements to UI, you'll need to use commas to separate them. This might seem that this is one of those things I noticed a lot of people kind of struggling with. So a lot of the times, if your UI component isn't working, look for missing commas. On the server side, like I said, the server component is defined within curly brackets. So that's basically our notation for code block. So basically that is just like normal R code. So code is separated by line and white space and all of that. So we've have these two components, UI and server. So um, they have actually communicate with each other. So the key with Shiny is this is a little bit untrue, but I find it helpful for people to at least think about kind of how things are going. So UI and server, they're both kind of these components that are running simultaneously, and they're listening to input and output from each other. So the way UI kind of communicates with server are these two objects. They're kind of the input object and the output object. So the input object basically has a lot of our controls. We'll look at that in just a second. And output is basically where those plots are generated or tables or any sort of output that the app generates. So with the server component, it's going to listen to input. So it's going to listen to those controls. And then it's going to kind of do some calculations and put that into output. So we'll kind of go over this until you're sick of it, but I just want to kind of introduce the basic idea. So there's kind of four components, UI and server, and they communicate with the input and output objects. So just taking a quick pause. Are we okay to move on? Any questions? Screens up. Give me a thumbs up if you'd like me to move on. Okay, great. So this is the data set we're going to be using. So I just like this data set because, it's all over the world. So these are biopics. If you don't know that term, it's short for biographical pictures. So these are movies about famous people or infamous people. And so I just wanted to show you kind of, oops, sorry. So there are a number of different columns in here. So we're going to be working with box office and some of these other columns. But you can see that there is a title for each of the movies, which is important, country, year of release, and things like that. Okay, so the first thing we're going to be doing is we're going to be adding a plot to that app. So we talked about that kind of bare skeleton. So let's add that. So I'm going to go over this and then we will look at it in the notebook and try things out. Okay, so this is a ggplot. You'll notice that I took the AES function out of the ggplot. statement here. I like this. I learned it from Gina Reynolds. She taught with a great ggplot2 flip book. But I just really like how it kind of separates things out into multiple steps. So we're going to take a couple of the columns in our data set. So we're going to plot the year the movie was released. And then we're going to plot the box office numbers. So these don't exist for all of our movies, but they do exist for a decent number. And then we're going to color by the type of subject. And then we'll use our good old friend GeoMPoint to make our plot. So this is what that plot looks like. Sorry, it's kind of hard to read, but the main point is that we've got a scatter plot here, and it's colored by type of subject. So what we're moving towards, not yes. If someone could please paste the link to the website for Ahmad, that'd be great. Okay. So there's a couple things we need to do. So remember, UI is where we're going to generate or display our plot. So we need to use this function called plot output. And this is going to display like ggplot or other graphics. And it's got this argument movie plot. So where does that come from? So to understand that, we'll need to move over into the server object. So when we basically make a plot to for our Shiny app to render, we need to put it in the output object. So we put it in the output and we use the $ notation to put it into that movie underscore plot slot. Um, and then to the actual code that we're going to use to generate our ggplot, we put in this render plot um, function. Notice that we've got kind of that parentheses notation, but we've also got these curly brackets. So part of the reason we do that is so like, we can put in multiple lines of ggplot code. Otherwise, we might be limited to kind of a shorter little bit of code. So oftentimes when you're making a plot, you need to understand how to change a plot according to different kind of inputs. Yeah, thanks, Heather. Okay, so where do we put that code that we just generated for ggplot? So we put it into that render plot code. Um, and so that basically this is the start of a Shiny app. So we know this generates ggplot, and we're going to display it. Okay, so it is a Shiny app. It's not a very interactive Shiny app. Um, are we good to move on, or are there any questions? Okay, great. So again, like the key thing here to take from this is really that we need to use render plot to kind of generate our plot, and then we use plot output to display the plot. Okay, so now we can add a control. So what we can do is we add this to the UI. We can use this select input function, and this is going to create like an input control. So we can switch off by country, type of subject, race, and sex. So the thing to note is categorical variables is predefined in this case. So it's a vector, a string vector with these different kind of entries in the vector. So this is a variable we want to color our plot with. So how do we wire that in? Okay, so now we basically remember we have to add a comma after plot output. We're going to add in that select input code here. And again, so this is going to generate our input, and we want to wire it into this color aesthetic. So it's not wired yet. So I'm going to show you what we do in just a second. But again, remember the commas. This is one thing. I think it's actually great. Like, an LLM is good at catching these things. I'm terrible at catching these kinds of mistakes. So I think this is a really great use for using like an LLM here. So how do we wire our select input into our ggplot statement? Okay, so we have our select input, and we have assigned it this ID called color select. So um, color select is an input, so it lives in the input object. So what we're going to do here, um, I had kind of a little more easier to understand code, but unfortunately, this is kind of the way we do it in tidyverse now. It's a little hard to understand. So what this is doing is you'll notice there's this dot data here and these double brackets. So this what's in this input color select is a string, so it might be country of release. Um, and then, so we use these double brackets essentially to select that column in the data. So this is a thing in the tidyverse called data masking. I used to do this in a different way, but this is the recommended practice. So let's kind of take that apart. So this dot data, this is kind of something that exists in the tidyverse, and we're using these double brackets to basically select that column. So basically input $ color select is going to have something like um, gender of a person, something like that. So that's a string, and then we use that to basically select the column. So this is where does that data come from? Yeah, so this is why I find it a little hard to kind of explain this. This is, and someone else, please weigh in, because I'm not always 100% knowledgeable. But data is kind of the way within the tidyverse to refer to the data set itself. I find it to be it's a little confusing when you first kind of encounter it. But yeah, so this kind of represents our data set within the ggplot statement. Uh, Heather and Joki, do you have any other insights about that?
Yeah, so as Martine said, it would be the biopics.
Yep,
Uh, so in this case, so
yep,
your first argument to ggplot will be a data frame, and then in basic ggplot2 usage, ggplot usage, your that's the data you're referring to for the rest
yep.
of the time. Sometimes you can make things more complicated by introducing other small data sets, but
Yep.
I think probably in the examples
Mhm.
here, we'll just be using one data frame, won't we?
Yep. Thanks, Heather. And yeah, thanks, Aubrey. That's good to know that the dot data comes from Erlang. I think you're right. Um, okay, so let's talk about this is just a kind of diagram. So we've got our UI. Let's talk about the flow when we change our control. So we've got that select input. So someone changes that value. So that goes into the input object. So the server, again, remember it's listening through that object. It's going to give us it's going to get that value. And then it's going to use that value in the render plot statement. So that generates a ggplot that goes into the output object. And then we display it with this plot output function. This this is not strictly how it works, but this is kind of in terms of when you're getting started. Um, I I want you to kind of keep this mental model in your head. So any changes in your inputs are going to change the input object, and then the code and server is going to react to those changes. Yeah. So here's a link in Mastering Shiny talking about data masking. If you're if you want more information about this dot data notation. Um, so again, yeah, dot data is how we refer to the data sets in a tidyverse workflow or using rlang. Okay, so now we can let's open up our Posit Cloud project. And of course, my project went to sleep. One moment, please. I find that usually Posit Cloud like stays open just long enough for it to close down while I'm talking. The timing is magical. Okay, so first thing we're going to do, so we'll click into this app basics folder, and there's an R Markdown file here called 01 app basics. So we are going to basically try out that whole process. So again, please execute this first code. This set locale, so this actually sets our locale to China because there are some Chinese characters in this data set. If we don't do that, we're going to get all sorts of errors. So I have video for all of this. So if you get lost a little bit, the video is there to kind of catch you up in your own time. So some people like to do everything side by side with me. Some people just like to watch and then do it on their own time. So that's there for you. Okay, so one thing to keep in mind, so we are actually going to write Shiny apps in R Markdown code blocks. So this sounds really crazy, but R Markdown gives us all of the machinery we need to run a code block. So one thing is like when we execute, so this is our bare minimum code. So what we want to do is when we execute this, you may get a warning about a pop-up. So you want to enable the pop-up. So just to demonstrate that this is a working Shiny app, I'm going to hit run current chunk here. And you'll see that it opened a window, but there's nothing in it. And that's because we didn't put anything in it. So again, if you get that warning about pop-ups, enable the pop-ups for Posit Cloud, so you'll be able to see the Shiny app. So just give me a thumbs up if you were able to open the blank window. Okay, great. So again, just please, learn at your own pace. Please take your time. But like hopefully the demo will kind of help um, solidify a lot of these things. Okay, So the first thing we do, this is our ggplot that we are going to generate. Um, so this is exactly that same plot that I showed you in the slides. So what we're going to do is we're going to add it to our server object. So this is what that code looks like. So it's not side by side anymore, but you can see we have that plot output, and then we've added the code here. So that's going to result in this app. So this app just displays a ggplot. We can't control it. Not that interesting, but we'll get to adding the control. So again, we want to change. We want to be able to change the coloring by different kind of columns in our data set. So what we're going to do is we're going to add a select input here. And so you can see that we added it here. We've got a comma here, and we have our select input. So if we run this Shiny app, okay, we have a control. Um, we've got different columns here, but it's not doing anything because it's not wired in. And you can see this is where I define that categorical vars um, variable here. So you can see that these are the columns that I want to color the um, output by. Are we good so far? Just give me a thumbs up if you're okay with me moving on. If not, I'm always happy to go back. Okay. Okay, great. Okay, so now this is that part that was confusing is wiring that select input into our render plot. So what we want to do, so I left it as an exercise for you to do this. So what we want to do is add the input $color select. Remember that comes from our select input object. And I apologize if some of the terms are different, but so this is where we put our input color select here. And now we have a basic Shiny app. So you can see when we change the input select column, it changes the categories and by the different columns. So here is subject sex here, and then country. I don't know what this is obviously a very biased data set. I don't know why there aren't any countries outside of this. I apologize to my international friends. I don't know what the deal is with that. Um, so that's the basic idea of a Shiny app. Just to really kind of reiterate, um, we defined a plot called paired plot in our server function. We defined an input in our UI function, and we wired them together using the input object. So if you couldn't get that to work, this is just a version of the app that works. So there's also kind of the final version of an app. I just wanted to show you kind of the basic kind of way of kind of structuring the apps here. So this is actually a runnable app. You can run it, and this is what the kind of code you would generate to actually generate a Shiny app. So just want to pause. How's everyone doing? Shall we move on or? Okay, great. So yeah, for all of you who aren't or feel like you've fallen behind or anything, are there any things that you want me to over again? Or are there some technical issues that you're having? So sometimes Posit Cloud is not does not work for everyone. Okay. I'm going to assume that people who aren't kind of following along are just kind of here to watch. That's totally great. Okay, so that was our very first Shiny app. So you don't have to read this. This is the type is very small, but we are going to actually make our data filterable by a control now. So to do that, we need to use what's called a reactive statement. Um, so here, this is our ggplot, our dplyr code that we know and love. So we're piping here, and we're going to filter by year release that's greater than or after 1917. Just this is just a few rows of that. Um, so how do we change this? How do we change this so that it basically this value here is changeable by our Shiny app. So we need to use what's called a reactive expression, and I think this is where a lot of people get frustrated because it's very foreign to them, but hopefully we'll make it a little less intimidating to you as we kind of go through this code. Okay, so the first thing we need to do is we need to put our filtering statement in what's called in the reactive function. And notice that the reactive function also has the curly brackets here. So now we can put in our filtering statement. And the key change to our filtering statement is that we are going to use, so I didn't show the year filter slider generated, but I will show you that when we go through the code. So input $year filter. So this is a slider control. So this is going to give us some sort of number. We set the range, so like it might be 1917 or 1920, 2026, etc. So what is going on with this? So basically, we've got our slider input, and then so we need to pass that information on within this, what's called a reactive statement. So the way I think of reactives they are like kind of dynamic versions of data. There are other kinds of reactives, but for right now, let's think about it in that way. When you call a reactive, so it's actually what is returned is also actually a function. So this is that we're working in that kind of dynamic piece into our data here. So here's what the slider input looks like. So this is going to be our input for our filter. So we can set a min max and then kind of a default value here. And then we can add now we can add that slider input in UI. So remember you need the commas here. I'll kind of remind you that you're probably sick of me saying that, but just keep that in mind. So we're going to wire that in. So this is our reactive statement. So the reactive statement again needs to have some sort of input here. So how do we use this? So we use it much like we would use like the biopics data, but we call it with biopics filtered, and because it's a function, we need to use the parentheses here, and then we can basically use that in our render plot. Where when to use RMD and when to use app.r. Yeah, great question, Lizette. So in general, you will want to use app.r. Don't use RMD. I'll talk a little bit about Cordo dashboards at the end. And there used to be kind of R Markdown dash. Well, there still are R Markdown dashboards with Flex dashboard, but I do recommend if you want to go the dashboard route, you use the Cordo dashboards. I'll set, I think I have a link at the end as well. So hopefully that answered your question. Okay. So again, this is where I always get tripped up. I define the reactive and then I forget to put the parentheses after it when I call it. So here, this is an extra little bit. We can use the REQ function, the rec function, short for require. So like our reactive is not going to work unless we have a value here. So there are some cases where this is very useful. Okay, so let's get into the reactives.rmd file. So I'm going to close this up. Okay, that's fine. So we'll go into reactives, 02 reactives, and we'll open up this RMD file here. So this should all be okay, but I do like to kind of run the setup chunk just to make sure everything's all set. Again, here's a video for you if you want to kind of catch up in your own time. Okay, so here is we've added the slider input to our UI first. So if we run this, again, we have the control, but it doesn't do anything. We need to wire it in. So we're going to take this kind of filter statement. Oh, oh, I think it's year of release. Sorry. Sorry if that's not working for anyone. Oh, okay, we'll fix that in a second. Okay, so this is where we're going to wire it in. So just in terms of everything, so remember our input is called year underscore slider. Yeah, thanks, Martine. So we'll call this input year slider. And then, so this is our reactive statement. So to call it, what we need to do is put that here. So biopics filtered. And then you'll see again, it's a function, so we need to call it with parentheses. So this should work theoretically. Um, okay, 1 second. It's kind of a reason I do this. Oh, missing a parentheses here. That's what's going on. No, that's right. Okay, well, unexpected. Okay, just 1 second. Okay, there's a reason why I have like the final version here. Um, so let's see if we can find out where we went wrong. We used, oh, we forgot to use rec here. And then we've got year release and year filter. Okay, so I filtered this so it's going to be all of the movies before the date that we set, but you can see that this slider does work now. Okay, so believe it or not, those are kind of the two major things that you need to know about Shiny. Um, so let's pause. Any questions this brings up or any thoughts? Um, and again, um, this is one of those things. I find part of the reason why it's hard to learn Shiny is that there are multiple components that you have to keep track of. So be patient with yourself, be gentle with yourself if you're not immediately getting it. Okay. Are we ready to end on tooltips? Give me a thumbs up if you're ready for me to move on. Feels more intuitive to start with server code. Yeah, great point, Dana. So, yeah, I kind of allude to that with when we talk about building the plots. So remember in the first R Markdown notebook we looked at, we started with generating the plot. So yeah, what usually happens is that you will have a plot that you want to make interactive. So you kind of work on your ggplot code, and then you can do and then that's when you start wiring things into it. Did that answer your question? Okay. So again, this is becoming outdated knowledge. When I said there's Plotly is being sunsetted, strictly what's going on, I'll talk about that in just a second. If you don't know what Plotly is, it's a JavaScript library that helps make your interactive plots more interactive. That's really badly phrased. But anyhow, we use it in R with the Plotly package. So the documentation is no longer supported by Plotly. It's user maintained now. That's usually a bad sign that Plotly is going to drop support for R. So this is all information about the Plotly package and like the Plotly documentation for R. So just keep that in mind. You can still use it for right now, but just keep an eye on it. Like I said, I think one of the best alternatives is gGIRAF. It's very similar in terms of the notation, but it uses different geoms than what we use in ggplot, but it's very interchangeable. I didn't have time to kind of work on that, unfortunately. But there are other alternatives. There are other libraries that are available via what are called HTML widgets. Um, but I would say gGIRAF right now is kind of the big kind of alternative to Plotly. Okay, so how do we actually make a Plotly plot? So we generate our ggplot as usual, but we need to put it into and so I'm assigning it into the my underscore plot object here. And then there is a function called ggplotly within plotly that we can call that will make our visualization interactive. So the cool thing about Plotly, if you don't need to do any data filtering, there's a lot of good support for things like tooltips. So, you might think again, like, part of our job is to help people wonder about data. So what is this person over here? For some reason, oops, sorry. Um, okay. So you can see that it basically it only shows kind of those aesthetics that we kind of passed in. The thing about Plotly is that you can pass in what are called fake aesthetics, which are actually columns in your data set. So this is how we add more information to our Plotly plot here. So you'll if you're familiar with ggplot2, you'll know that there's not really a director aesthetic, but this is kind of a fake aesthetic that we're passing in so we can actually pass it into the tooltip. So we are also going to pass in box office. Um, so now we have all of that information and we can find more information about that um, that particular movie. So here's The Sound of Music. This one is American Sniper, so it made quite a few in the box office. Um, Lots of early movies. So Jack Conway. So there's a lot of movies kind of that are bunched up here. So this is not like a complete data set, but there are some recent ones. Here's King's Speech, Aaron Brockovich, etc. So we added those fake aesthetics into our aesthetic statement. So there's two other changes you need to make Plotly use a Plotly object. So you want to change the plot output function to Plotly output, and then your render plot to render Plotly. And then with that, this code here is going to work with the tooltips. So let's take a look at what that looks like. So instead of plot output, we change it to Plotly output here. And instead of render plot, we change it to render Plotly. And this is our code, our original ggplot code. We need to assign it into an object, and then we call the ggplotly function on that object. Okay, so yeah, this is the last little bit. And then, basically, pause for questions, give you some further tips. So again, this is going to generate that plot. And then you need to use a ggplotly function to generate the interactive version here. Okay, so let's actually wire this in. So remember, we're not adding any controls. We're just adding more information into our Shiny app, into the tooltips. Okay, so you can see here, now we have, this is a working Shiny app. We don't have any controls. I'll show you what kind of the full app looks like in just a second. But now we have those tooltips. So here's a couple of exercises. I'll leave that up to you all to do. The solution is under here, and we'll wrap things up. So Lizette had a great question. When to use RMD and app.r. So in general, apps are used in a folder with app.r. The reason I did it in R Markdown was just it's easy to kind of launch them and show you the changes. So in general, you're going to be putting your app in a folder, and your code is going to be called app.r. Okay, so just want to show you what the full app looks like. So if you go into O4, so we've got this app.r here, and we can run the app. So this all should work theoretically. Tooltips work, our filtering works, and yay. That's the basics of a Shiny app. Just a few notes, and then we'll basically break, have some networking time or time for questions. Okay, so yeah, this is how you kind of start a new app as a project. This is in RStudio. I didn't put together one for Positron. Sorry. So there are a lot more information about all of the different control inputs and outputs. So I want to point you to the Shiny widget gallery here. This shows you all sorts of controls. Yeah, so like, you can have an action button, you can do checkboxes, checkbox groups. So this will give you the code that you need for that. So here, this is gives you in the UI, like, the code that you need to kind of generate that. So there are a number of different layouts. So I showed you how to use Fluid Page. This is kind of the default, but like again, Quarto dashboards, I found them to be really helpful. They're set up a little differently than normal Shiny apps, but the documentation is very good. There's also the Bootstrap library, which is called BSLib. So these are more controls and different ways to lay out your Shiny apps. Um, if you just stay with Fluid Page for a while, that's great. Like as your apps become more and more complicated and you need more and more controls, these two methods will give you more control over laying things out. So I teach an intermediate Shiny workshop for Cascadia R every year, where I talk about Shiny modules. But so the crucial thing to note is that a lot of those kind of fancy visualizations that you see are actually what are called HTML widgets, which are basically these libraries that have been wired to work with Shiny. So there's a lot of them. One of them that you might be familiar with is Leaflet. So Leaflet is an HTML widget. You can add all sorts of cool Shiny controls with it. Um, R2D3, I don't know if it's being used that much more nowadays, but there's a lot of really cool visualizations in this, what's called the D3.js library. And so this will enable you to kind of use those. So let's talk about how you get Shiny up in the real world. The fastest way to do it is to use Posit Connect Cloud. Will let you publish apps. There's also shinyapps.io, which I think shinyapps.io is still around, but Posit Connect Cloud seems to have a much kind of smoother workflow in publishing. Shinyapps.io takes a little fussing. It's a little more fussy. You can also host your own Shiny server internally. I I recommend you do it for educational purposes, but I think if you're in industry, you need to have something that like uses authentication and everything. I learned a lot by hosting my own Shiny server when I was a postdoc. Um, but I don't like you can use it, you can deploy it. Um, but like a lot of times, like I said, like industry, you really want to have authentication and stuff, and it doesn't do that. This is just some notes about deploying apps on shinyapps.io. Um, so my goal really was just to give you enough Shiny knowledge to start learning from the examples. So definitely go to the gallery, look at people's code. There's a lot of extra things that I didn't talk about today, but you have enough kind of knowledge to kind of start learning. Just some final tips. So, a lot of people try to have R do a lot of things in the background. That's kind of a recipe for making things run slowly. So pre-computing as much as you can, and then working from like a single data frame. So there's a lot more about like kind of dynamically updating Shiny apps, but um, at, that's kind of an extra thing. I will point you to Mastering Shiny if you want to kind of understand that. There's also Shiny Live. So this basically uses the power of WebR and WebAssembly to basically you make Shiny apps that run in your browser. Lots more information is at that. I would be remiss if I didn't talk about Shiny Assistant. So, like, I think enough, like, part of my job is really to install the mental model for how things work, all of the concepts, and then you can use Shiny Assistant to kind of help you out. Um, this is basically wired into Claude, I believe. Uh, Although I think they let you change the LLM behind it, but this can be really helpful. Sometimes if I forget syntax, I'll ask Shiny Assistant. Um, and again, so Mastering Shiny is the textbook for really kind of getting into Shiny and really understanding how it works. I did not get into reactivity because it is kind of its own course, but Hadley really lays a lot of things out really well. So just a few acknowledgments. Like I said, I've given this workshop for quite a long time, taken a lot of feedback from everyone, so that's it's always helpful. FYI, eCharts for R is an alternative to Plotly. Oh, great. Thanks, Dana. Have I successfully packaged a Shiny app as an exe that is portable so I can run it anywhere with no need for installations? So I haven't done it. You can wrap Shiny apps into what are called Electron apps. I don't know too much about that. Let me see if I can find James Balmuda has kind of done some work on this. Uh, okay, so I'm going to send this video here from James Balmuda. Um, so he has a package called Shiny Electron. Yeah, so Electron apps are kind of finicky. So it may not work on everyone's machine, but he's doing a lot of work to kind of make it portable across um, di different platforms and machines. So this is my information. So keep in touch. I do a sporadic newsletter called Ready for R. So if you want to know, you know, if you want to know more R tips in the future, this is my Blue Sky and this is my webpage. Okay, that's all I have. Yeah, and thanks everyone for sticking with us.